All right, thank you, Justin, and good morning, everybody. I hope those of you who survived yesterday's beer-a-thon was are still, reeling from it. But nonetheless, welcome. It's always exciting for me to be here. And last year, as someone was mentioning, I had an interesting story to tell from. Thank you, 10 minutes. I had an interesting story to tell coming to the Science Center. But today, my topic is I had an AI epiphany on my way to the Science Center. Something happened along the way. Now, let me try and tell you the story. First, I like to quote this guy. He's one of my favorite physicists. I never had the luxury or the privilege of being taught by him, but Richard Feynman, Nobel laureate, 1965, during his acceptance speech, he mentioned this. He said, a very great deal more truth can be known than can be proven. In other words, we will know a lot more stuff, but we may not be able to prove it. We may not be able to prove it at the time when we know it, but at some point we might be able to. So I'll leave this quote here, and I want you to just mull over it. So the topic today, or for this entire event, is artificial intelligence, machine learning, and personal assistance. I have it divided into 3 sections. So let me start with the first one, AI. This is your traditional definition. It says, intelligence exhibited by artificial, non-natural, man-made. I'm not sure whether it has to be man-made. Why do we have to be part of the equation to create artificial intelligence? Why can't it happen on its own? But this is a definition that is being offered. Okay. What about machine learning? What is machine learning? So this is from a book which is deemed to be the definitive guide for machine learning, written by Professor Tom Mitchell. It says, it's a computer program is set to learn from experience E, with respect to some class of tasks. So you have experience, class of work that you need to do, and you measure the performance of the work that you did, and if its performance at the task in T as measured by P, if it improves, you have machine learning. Whether you agree with this or not, this is what his statement is, and this is how he defines machine learning. So I'm hoping that this event, this weekend, you'll be able to pick up some of the ideas, whether to debunk it, or to enforce it, or entirely new ways of looking at it. So let me then move into the last word that was in the event title, personal assistance, or personal assistant in this case. What does it mean to you? Anybody know who this guy is? Shout it out. Isaac Asimov. You are correct. There's this guy. Now let's hope this audio works now.
The first law is as follows. A robot may not harm a human being or through inaction allow a human being to come to harm. Number 2, a robot must obey orders given it by qualified personnel unless those orders violate rule number 1. In other words, a robot can't be ordered to kill a human being. Rule number 3, a robot must protect its own existence. After all, it's an expensive piece of equipment. Unless that violates rules 1 or 2. A robot must cheerfully go into self-destruction if it is in order to follow an order or to save a human life.
You know what he was talking about? He was talking about robots. Our personal assistants robots? That's a question you need to answer for yourself. The event says personal assistant. Does it equate to a robot? Maybe, maybe not. But what is a robot? The word robot came from a word that was used in a Czech play in 1924. In Czech, it's called robota. Is there anybody from Czech here? Czech Republic? I'm sure there's somebody. Someone, maybe he's not here yet. Okay, there will always be somebody from Czech Republic. But, but what is interesting is robots is not something that happened in the last 100 or 200 years. It has historically been from the Iliad. It was first mentioned not in the way we know today. It was mentioned by one of the Greek gods. I need to get his name correct. Hephaestus. I hope that is pronounced correctly. He was the Greek god of masonry and making things. So he is deemed to have made what looks like animals to ward off evil for the Greek aristocracy and so on. So that is the earliest reference we have of what is called what we call today a robot. It may not be moving, but that's what it is. So what Isaac Asimov was saying in the video clip was talking about the 3 laws of robotics. And I'm sure you can read this as well as I can. Yeah, I got 5 minutes, so I better be quicker than that. So there are 3 laws of robotics. It may not injure a human being. Now that is a fundamental law. Robotics, personal assistants should not be injuring us. Do we accept that? Or do you think it's okay for robots to injure us? Silence means you don't mind doing that, right? Okay. Second law, it must obey orders given by human beings. I guess most of us are human beings here, right? Except when such orders would conflict with the first law. So refer back to the first law. And the third law, a robot must protect its own existence. That's interesting, isn't it? The robot must protect its own existence. As long as such protection does not conflict with first and second. So it's kind of reinforcing the fact that we are the top of the heap. Not sure for how long, but we are the top of the heap. Now, there is a very interesting XKCD cartoon that describes why is it that Isaac Asimov placed the laws in the sequence he placed. And I won't read through this. I encourage you to have a look at 1613 XKCD cartoons. Because if you rearrange the order of the laws, you got different outcomes. So he's trying to show you what the outcomes may be if you reorder the 3 laws. Especially the last one here, right? If you protect yourself, that means the robot will protect itself as number 1. The second one is to obey orders. So it has to protect itself. Only the second thing is to obey orders. And the last one is don't harm humans. So what does that mean? It means robots will be doing what they need to do. They may obey orders. However, they may not necessarily protect humans because it's the last one to do, right? So it is actually very interesting. When you think about it, there are some truths in this particular sequence of how the laws were ordered. Now, Isaac Asimov figured that there is something that is missing. So he created a zero-earth law. Actually, not him. Somebody else proposed to him and he added it. But it reads very much like the first 3 laws. So the 4 laws, the 3 plus the zero-earth law, is what we have on the screen right now. But the key thing here is, this is what we have to understand from our own, what we do. What does it mean when we create AI systems, when we have machine learning and we have personal assistants? What does that mean? How do these laws help us do the right thing? How does these laws help make sure that what we create are created stuff that works for us? Unfortunately, we don't have a good enough answer up until earlier this year. So, let me go back to the definition of AI. You already know that. There was a conference earlier in January this year that figured, we need to address this because AI is getting to be very interesting with open source projects like TensorFlow and so on. What do we need to do to assess and understand what can we accept, what can we not accept? So a whole bunch of people got together in January in California. And they have created this thing called AI principles. The AI principles have got three broad categories: research issues, ethics and values, and long-term issues. There are, believe it or not, 23 items here. I'm not going to go through all 23 of them, but I'll highlight some of them. So under the first category, research issues, the ones in red is what I think you may be wanting to read. If you can read, is it clear enough? Is it big enough? The first one says the goal of AI research should be to create not undirected intelligence, but beneficial intelligence. I don't know what beneficial intelligence is. Yeah, I got 1 more minute. Okay. What is beneficial intelligence? Benefiting us, I suppose. The third one, science policy link. There should be constructive and healthy exchange between AI researchers and policy makers. Who are policy makers? Government, perhaps. Perhaps people who create technology, corporates. There has to be a healthy exchange of ideas. Let's look at the second category, ethics and values. This is a long list. Let me highlight the human control, number 16. Humans should choose how and whether to delegate decisions to AI systems to accomplish human-chosen objectives. So we are not ceding everything to AI systems. We still retain a veto power, as it were. Now, whether we all agree to this, I don't know, but this is something to think about. Yes, I ended. Thank you. I haven't ended yet, but... And the long-term issues. Let me point out the, 20. Number 20, that's an interesting one. Advanced AI could represent a profound change in the history of life on Earth. Are we all on Earth, or we agree we are still here? And should be planned for. That means we are expecting AI to change life on Earth. We have to plan and manage the commensurate care and resources. Now that's a very profound understanding. Now whether or not we are going to give up, whether the planet Earth will be able to sustain us along with the whatever we create, is something that we need to negotiate and get things done. So I would encourage you to go to this site, futureoflife.org, AI-principles, and contribute your comments, your suggestions, or whatever it is that you think you want to contribute to this conversation, because this is something we all must have. It is not for somebody else to do it, it's for us to do it. Now let me then switch a little bit. What does AI, what does machine learning, how do these things relate to what you and I think most of us right now are conscious, right? Are we conscious right now? Do you know you are here? You don't know why you are here, but you are here somewhere. We are conscious. What does that mean? Can an AI system have consciousness? I don't know. These are questions that I want to leave with you. Can AI systems have imagination? Do we have imagination? Remember the big rainbow thing, imagination. Who says that? One of the cartoon characters, right? Imagination. And the last one here is on curiosity. We are all curious creatures. That's what brought us here. Yes, I will end it. Thank you. So not yet. I will end it here. Okay. So let me bring back to the first quote by that I showed you with Richard Feynman, which is, a great deal more truth can be known. We know a lot of stuff, seem to be, but we can't really prove it. How do you prove consciousness? How do you prove curiosity? How do you prove imagination? That it is really what it is, similar to what we do. We need to figure it out. We kind of know what it is, but we can't prove it yet. With that, I end, but I want all of you, because we got a good Wi-Fi connection here, I want to test these things out. Can you go to, there is a project called Servile Project. If you want to scan this QR code or take a picture of it, you're welcome to. This allows you to use the Wi-Fi network to communicate without going through the GSM network. Okay, so this is something we did 2 years ago at FOSSASIA. I want to now, because we got a fairly robust Wi-Fi network, I hope it won't break, but we'll test it. We want to make sure this works. So please try this out. Okay? Now with that, welcome to this event. I think this is going to be exciting. There's going to be a lot of stuff to learn. So have fun, enjoy. Thank you.